This is a hopper. First question you're asking is, what is a hopper? Well, a hopper is essentially, it's a storage unit and a funnel all in one. They come in round and square. Round and square size for size is going to hold more volume. So depending on application, the square one might be more applicable than a round one, but essentially they both do the same thing. They hold stuff and they discharge stuff, however you want it discharging. I think every fabricator's made a hopper at some point. It's one of the easiest things we can do as fabricators, and it's one of the most useful things we can know as fabricators as well. And as in most fabrication problems, there's more than one way to do this. I'm going to show you the way that I do this. So less talking, more drawing. So let's get cracking on with it. Let me show you how I would do it. Here we have a 2D drawing. I've got all the information that I know already on the drawing. As you can see, that's the end elevation. I've drawn the plan view in. Don't need it for this development, but I've drawn that in to show the different views. So that is a plan view, and that is the end elevation. All the information we need to make this is on this elevation here. That is a true length. That itself is a true length. That is a true length. That is a true length. So to plot this side, and all the sides are equal, they're all the same, they're all symmetrical, we're going to plot one. As we don't need a plan view, we might as well just look at what we do need to see. That's better, we can see it now. So I'm going to work up a centre line is where I'm going to start initially. So I'm going to, first of all, I'm going to plot a centre line down there. Like I said, there's a couple of ways of doing this. One way is to draw it out, which is what we're going to do now. And the other way is use Pythagoras' theorem by a squared plus b squared equals c squared. What I'm going to do is I'm going to do that afterwards. What I like to do is draw it out first and then cross-reference and check that dimension with the dimension I've actually ended up with. Centre line drawn, we can put on the information that we do know. So I'm going to project this top line across just to create this datum edge. I'm going to take the dimension from this point here and plot it down on our centre line. First line drawn, this represents this flange here. Obviously, take off any metal thicknesses that you might need to take off before developing this out, but this is what I'm using. So that's my first step there. The second dimension I'm going to take is from there to there. Again, metal thicknesses will come into play here, but in this instance, it doesn't need to. I'm going to take this dimension from here to here now. This is obviously a true length in itself. We don't need to do anything else apart from get the length of it. Once we've got the length of it, we can just plot it straight onto our centre line, and that will give us this bottom line here. The last bit on this development is going to be this edge here, and all I'm going to do is take that dimension there, from there, and plot it from the last point on the centre line to there, and mark it across. And that is the total length of our development. That is all using all the true lengths. Now it's just a simple case of plotting as widths. Again, these are true lengths, so we use this size again. I'm going to check this size I need. In the fabrication shop, you'd obviously take off your metal thicknesses, step it onto centre line in the right place, mark both sides, and that is that dimension there, and that will be the same at the top on this line here also. The opening at the bottom, again, this is a true length. I'm going to do the same thing, plot it on the centre line, set my dimension, and on the second line up, obviously, step it onto both sides. Last bit, we've got a flange on there. We know the outside size of that, so I can step that onto my centre line and mark that up on the bottom of my development. And exactly the same process at the top. We know the top size of the flange, centre line to the outside. On the top of our development this time, I can mark that dimension there. All those points marked on, I'll fill them all in now. So there we have it, the finished development, as simple as that. Notice these two folds, they are in hidden detail. That is because they're folded away from us. They're folded away from us because I want to make the green side the outside. And as final double check, like I said, we're going to use Pythagoras' theorem, which is as simple as a squared plus b squared equals c squared. So a squared in this instance is 130. Squared means times by itself. It's 130 times 130. B squared, in this instance, it's 75. So it's 75 times 75. So 130 times 130 is 16900. 75 times 75 equals 5625. Add them both together, and that equals 22525. Square root equals 150. My size is 150. My size is 150. Drawing and check complete. We're happy that everything's good. From this one development pattern, we then create our hopper. So there we have it. It's a really simple process and it's a really simple check. And this is really relevant to fabrication. This happens a lot. Whether it's a square to square transition piece or whether it's a hopper, this information is a good thing to have in your toolbox. And it's also a good basic understanding of true lengths, how they work, before we go into something a bit more technical like a square to round or a breeches piece. And so another thing for the shelf, and another development for the wall. And what's next? I don't know. You can decide if you want.